I happen to know that a large portion of my viewers lay awake at night wondering just how this old Tony, guy who'd never talk in the third person mind you, holds large material in the mill with access to machine the entire top surface and not worry about cramps. Today is the day I finally answer that question. And the answer is, I don't. Not in any good way anyway. Allow me to explain. Say I wanted to, not that I do, but hypothetically speaking, say I wanted to machine the entire top surface of this plate. This plate won't fit in the vise. So if I want to machine it and have it not fly away, I'd have to hold this part down some other way, right? Yeah? You got my back on this one? Usually that means clamps. And clamps like these, 99% of the time, are absolutely great. I love them. My kids love them. My dog loves them. Irreproachable character. Except in this situation. Here, they're simply in the way. There are areas of the surface I can't machine because the clamps are there. And I'd have to play games where I machine most of the part, then move those clamps around, then come back and clean those areas up. It works, of course, but it's a lot of extra time. And having to move those clamps around and machining different parts of the surface at different times leaves inconsistent tool marks that, frankly, don't help my street cred. I recently made this mounting plate for my baby 4th axis. Now this part did fit in my vise, but it was up so high in the jaws and my vise isn't the bestest. Long story short, I had to be very careful flipping it over and I ended up having to chase out about a tooth-out taper that was driving me mad. Okay, I only had to flip it one extra time after measuring the cross taper, but I'm told a little melodrama helps with the YouTube algorithm. But let's not lose sight of the big picture. How cool would it be if I could just clamp big parts right to the table, unobstructed? To be honest, I don't know how cool it'd be, but that's why I've gathered you all here today, to find out. This problem that we're talking about, holding work on a mill without interfering with the top surface of the part, is a problem older than time itself. And a problem, consequently, that's already been solved. What we're talking about here are edge clamps, sometimes called table clamps or low profile clamps. Mighty Bite is the trade name I've always heard thrown around, but I think there are quite a few companies that make these. Truth be told, I was just going to buy some. I still might. Nonetheless, I got this itch. And while scratching that itch, I got to wondering if I couldn't just make my own low profile clamps. Better, more awesomer ones. And, pardon my French, but gosh darn it, I think I can. Make my own, I mean, not necessarily the better part. But we'll see, won't we? Let's start with the wish list. Design specifications. First, they have to be really low profile. Dare I say, ultra low profile? I'm thinking maybe somewhere around 1/4 of an inch. 6 millimeters? I think that's already pretty small. And for parts we're trying to hold any thinner than that, especially if they're large, side forces might cause the parts to buckle up in the middle. Thinner than 1/4 of an inch, and I think we're getting into a different realm of work holding. So ultra low profile, that's number one. Second, since we've already shot ourselves in the foot with that first design requirement, the bulk of the clamp, the whole clamping mechanism, I think, is going to all have to live down in the T-slot. I think that's true, right? 1/4 inch isn't a lot to work with unless we're talking very light clamping, and what's the fun in that? First order of business is to stake our claim, see how much room we have to work with. This is a cross-section of the T-slots in my milling machine. Little known fact, T-slots is short for Tony slots. And that's about it. All the information we need to lay out the clamp. Now, I've already got something in mind, but I've laid out the basic information here. I've also added some perpendicular lines so I know where I'm at in the side view we're about to get into. Let's assume the thinnest plate might be around 1/4 of an inch, 6 millimeters or so. I'll stay 1 millimeter below that and maybe throw in about 5 degrees of clearance at the toe, like at the nose, so the nose always bites first. That little turtle head of a clamp pokes up out the top of the table and will pivot around a pin that's up against the bottom of the T-slots. That's what that 6 millimeter 1/4 inch circle is that you're seeing there. The 2 dashed lines I just dropped in are the same length. This is arbitrary for now, but for sizing purposes, I'll start with a 1-to-1 ratio on the seesaw. This effectively sets the size of the clamp left to right. If my back were up against the wall, which it isn't, this could probably be shorter. Now the vertical dash line is where the tapped hole and screw will be. There may be something to be said about angling that threaded hole a bit so the screw contact isn't at such a weird angle. But I don't expect this to need a ton of range of motion, and perpendicular is easier to machine. The rib you're seeing on the underbelly, I've gone back and forth on. The idea is to keep the clamp from just falling down into the T-slot. The cross pin, the dowel pin, is smaller than the T-slot, and this rib maybe helps keep the clamp up off the floor. Again, probably not necessary. Once you push this clamp up against the work, it won't have anywhere to go anyway. Just to help get this across, here is an assembly view. This isn't really necessary, part's really basic, but turning the screw adjusts the clamp. Turning the screw down pushes the clamp into the work. That second hole you see now I added after the fact. It's primarily to reduce hydrodynamic drag, and only secondarily to help me set up the part when I flip it over for machining the other side. Word of warning before we go getting all ahead of ourselves. This is not the safest or maybe even the smartest clamp design in the world. Let me just make some room for an inset graphic here. This clamp works like a seesaw. If we assume the workpiece doesn't move, all the clamping force on this screw ends up pushing up, trying to lift or break those Tony slots. I think all of the other low-profile clamps sort of sandwich the T-slot. There's no jacking force trying to break anything. On the other hand, what I'm doing isn't much different than a strap clamp. Strap clamps also pull up on the T-slots, but I guess you could argue they have a larger area on the T-nut, and I'll just have a cross pin with like line contact. Long story short, it's my party and I can break my T-slots if I wanna. Let's head back to the bench and talk. As with all parts designed for CNC, these will have a stupid shape. Granted, it's mostly two-dimensional. They could just be profiled. Walk around the contour like a plasma cutter. Ideally, I'd have a flat plate of material and just cut a few of these out. However, I think I'm going to make them out of tool steel. I don't think I'll heat treat them, but they should be tougher than cold rolled steel. These are some offcuts from my pile. Now, depending how well you did in geometry class, you might notice these are blocks and not plates. Sure, I could just cut these to thickness, then mill out the shape. However, being the sort of fella that enjoys the challenge, this is D2 tool steel. And for the life of me, I couldn't tell you why, this stuff wreaks havoc on saw blades. In fact, maybe you can make out a partial cut here. I tried to get through and I just gave up. On paper, this shouldn't be much different than cast iron, I think anyway. But for me, alas, that's not the case. I'd need 4 bandsaw blades to cut 4 pieces out of this. Now yes, I could just karate chop them right to size, but then I couldn't tell you about plan B. I really hate to point fingers. I think you made a mistake here. You remember that lobe that was supposed to be on the bottom to keep this clamp up off the bottom of the T-slots? Well, it's not there. I'm willing to bet when you picked up the profile in the CAM software to do the contour, you probably picked the bottom, and that didn't include that little lobe. So it just machined right through it. Anyway, spilled milk and all that. Now we just need to get this thing off of here, and we'll do another one. I hope you appreciate me showing you just the most important parts of making your own tooling. There is one tricky bit here. Some of you may know these slitting saws don't have a key. Hold on just one second. Here's a bigger saw. Notice, hopefully you can make out, that has a key slot. That's what drives this saw. These smaller slitting saws don't have that, and they rely just on the clamping pressure to drive them. That said, you want to be careful how you install them. Let me see if I did that right. The cutting forces will be trying to turn it this way, which is the same direction that the screw tightens. You could install this saw quote unquote upside down, but then under cutting loads, it would tend to unscrew the whole thing. That's a bad thing. The way it's installed now, it tends to self-tighten. There we go. Let's see how it works. I'm man enough to admit when something scares me, and this scares me a little bit. I've never CNC slitting sawed anything before. On top of that, as I was putting together the cam, the software only recommended I do 4 times the saw thickness in terms of depth of cut. I don't know if I knew that. If this were on the manual mill, I would take the saw as deep as it'd go up to that arbor and just adjust the feed rate, work it through by hand and sort of feel it out. Have never had any problems doing that. This program, on the other hand, because of the diameter of the saw, the size of the part, sort of the size of the stock, and only going 4x this thickness, it seems like it's going to take a lot of time to sort of inch its way around this whole part. But if all goes well, nothing will break, and I'll just have a sliver holding that part to the stock. That was excruciating to do. So painful, in fact, I just took it over to the bandsaw. That's one down, one more to... I'm in a little arbor press here. You saw me ream those holes earlier. That was to a light press fit all the way through. But after that, I reamed a clearance hole about 1/3 of the way from each side. So that press fit is only sort of in the center. And to keep that from going too far, I've got just some key stock there. Hopefully those pins end up more or less centered. Oh, this isn't going to work, is it? They're done. Now the really fun part. We get to try them out. But before we get any further, I have a couple of announcements. I hope everyone's sitting. Since last we spoke, I got some exciting new stuff. First, you're gonna love this. I got something that I never even knew existed. Weed whacker dermatitis, or as me and my friends like to call it, phytophotodermatitis. Settle down, it's not contagious. I apologize if during this video you noticed some skeevy scars on my hands. I apologize even more if you haven't noticed and now I brought it to your attention. Hopefully this clears up, though it's looking pretty scarry to me. Frankly, I'm getting tired of being that one guy at the pool in the long sleeves. I'll do you the courtesy of not showing you the rest of my arms. Though honestly, it's mostly just my left forearm. It's some wild stuff. I mean, I've been whacking weeds since before the bosses were putting hits out, and I've never had anything like this happen. Occasional contact rash, sure, but nothing like this. Here's your PSA for the day. If you're planning on decimating some tall weeds, wear long sleeves. Unless you like looking like a tough guy with phototoxic scars on your arm. Or a leper. Could go either way. Second, HTP, the people that make the welders, reached out to me a couple of months ago now, maybe more, and asked if I wanted to take their newest welder for a ride. This thing. It's a multi-process machine, meaning it does MIG and TIG in one box. Stick too, I suppose. I floundered at first, except for my Leatherman multi-tool and that combo shoehorn cork opener I got for Father's Day. I've never been much of a fan of multi-function tools, especially something as sophisticated as a welder. But then they emailed me the spec sheet, and I just had to see it for myself. This is the HTP Revolution 2500. I think I'm allowed to show this to you. I'm hoping by the time my video airs, they'll have already announced it. To date, I've run a tank and a half of argon through the TIG side, the big tanks, mind you. Haven't even hooked up the MIG gun yet, but I'm having way more fun in this thing than a grown man should. I've been taking video as I play, and you might see some of that sooner or later. It's been a while since we've done a welding video. Welding videos are fun. If you're interested, go have a look at the spec sheet. If you have any questions, leave them in the comments, and if this is still here, I'll try to answer them. Anyway, let's get back to my cramps. I'd say I'm about 72.5% happy with how they turned out. I am particularly bummed about this surface finish. I went to a lot of trouble to specify a finishing pass. Even used a brand new 6-flute finishing end mill. Maybe I accidentally bought an unfinishing end mill? I don't know. These would have looked a lot nicer without the stripes. As I mentioned, I did lose the baby bump on the bottom here. Shouldn't be a problem to function, but it did end up adding a surface grinding operation. If that bump was there, I would have had to machine these from both sides, which would have made the sides parallel. Instead, I saw cut them, which left me with rough, not parallel sides. Well, one machine side and one rough side, which makes parts tricky to hold in the vise. Since these are a stupid shape and already had one flat side, well, they were a match made in heaven for a grinder with a magnetic chuck. The press fit on the pins was a little too tight. By the book, they should have been okay. I've made note to check my reamer size. Maybe it's worn out a bit. I should have run the reamer all the way through. Instead, I just used the tip. These didn't really have a through hole during that reaming operation. Anyway, there was a little bit of rupturing of the tool steel around the edges of the hole. That shouldn't interfere with how these work, assuming, of course, they don't explode around that press fit. Lastly, the face knurling, whatever you call it, worked pretty okay, though the ribs looked a lot bigger in CAD than they do in real life. I was going to use a regular dovetail cutter and hold these upside down in the vise, but when I was digging through my box, I found a weird upside down dovetail cutter I didn't even know I had, so I used that, with the parts right side up. Though with such fine details in tool steel in this D2, I probably should heat treat these. I can see those teeth falling off little by little. But let's see how they work, and I'll heat treat them some other time. You know how you can get pregnant using a dirty toilet? Well, you don't even want to know what can happen if you use a dirty milling machine. Not to mention, we'll be machining directly on the machine table, not in a vise. So it needs to be spotless. Give me just a second to, just for testing purposes, I'm going to use 2 of the vice's toe clamps to sort of squeeze up against. About there should do it. Those aren't clamped down to the plate, they're just stops. Speaking of which, I made 4 of these, but you don't really need 4. You'd have some sort of similar stop on one end and just 1 or 2 or however many you need pushing against the other end. These can be used opposing to do multiple setups. So in this case, you might have 2 on one side, a workpiece, a couple of stationary hold downs like stops, another workpiece, and then 2 more toe clamps. And they'd both be squeezing in on those center posts, hopefully keeping everything down. Now these should just drop right in here. Those look pretty good. Now they're maybe a little lower than they ought to be, again because that little belly isn't there, but I can pick them up a bit and push them up against the work. I'm biting a little bit more than, I don't know, 3/16 maybe. Now hopefully we just tighten this down with the right size Allen wrench. And I did not see this coming. So that clamp will pivot around the dowel. When I turn this screw down, the nose sort of drops, but it's just backing its way out. That clamping force that way, this way, is pushing the pin in the screw, the whole clamp, back that way. Maybe if I hold it in there. Well, that's a bummer. I really would have expected this to sort of bind before it slipped backwards. Now what? Let me think. We're going to have to try backing this clamp up with something else. Hold on. Okay, I got some T-nuts, socketed cap screws in there. Let's see if these aren't enough to back these clamps up. Oh, that seems to be working. Yeah, that's biting. Nice. I mean, sort of nice. It would have been nicer if they worked by themselves. Am I still below? Yep. Here's just a look from a different angle. That T-nut is bound in the T-slot, clamped to the T-slot. My little rocker toe clamp now can no longer back out and is biting into the material. All right, it seems like it's on there. I did have to tweak it, move it around a couple of times. Turns out this piece of aluminum is pretty much at the limit of my machining capacity. I'm going to try to take some facing cuts, but I don't have enough travel to come off the end here, so we'll be looping on top of here and coming off on this corner. The clamps do seem to be biting. Hopefully you can see those tooth marks there from that first setup, and they're sucking the part down to the table pretty well. Let's see what it does under cutting load. I might start at 20 thou depth of cut, 0.5 millimeter. Well, I missed the end of the workpiece. I had to bring these sweeping moves in, or as I mentioned, I run out of X travel on this machine. Feels pretty good though. I guess I could have just done rectangular step overs here and got this whole part. But I didn't hear any weird vibrations. Nothing seems to be working itself loose. I don't know if I should push my luck and go any deeper than a 20 thou fly cut, without going a lot slower, I mean. All in all, my approval rating of these little clamps may have slipped up a bit to 76, 77%. That was fun. A little bit of a roller coaster ride, but good times. For kicks, I measured the deviation from two opposite corners. Came into about 1/1000th of an inch. Maybe a little bit tighter if I'm feeling optimistic. Given I just sort of threw this on there, I don't know how flat this part is. That I think is reasonable to expect. All in all, I think a pretty good addition to the tool arsenal here in the garage. I think these warrant a version 2.0, but for now I think they'll do. That's all I got. As always, I appreciate the company and thanks for watching.